Hi everyone, this is going to be an introduction to the next lesson, lesson 4. And I know it might be hard to read, so I'm going to read it to you. It says, how far have you traveled? Suppose you go for a run in the coordinate plane. Well, why wouldn't you? Assume each side of a square is 1 mile long, so any one of these little tiny squares, 1 mile for each side. Let's suppose you start at the point -12, -5. So I'm going to plot that, okay? There. We're going to call it A. And it says you run straight to B at 4, -5. Plot that one also. And from B, you run straight to C at 4, 7. So we've done this, plotted out the routes, labeled our points, right? The question is, how many miles did you run when you were running from A to B? Okay, so this length right here, how many miles was that? And they told us that one of these was 1 mile, right? All right, well, this distance to get back to the axes was 12, right? So that's like the absolute value of 12. Absolute value is distance from 0, right? And it's always positive because this is a positive distance we went. It's just that we started on the negative side of the axis, right? And then we also went from here to here, which was 4. So this distance was 12, this distance was 4, total distance was 16 miles. How many miles did you run when you were running from B to C? Okay, let's draw that one. Oops. All right, well, same kind of idea, right? From here, I was 5 below the x-axis. So the absolute value of that -5 is just +5 distance. And from here to here, on the y-axis, we went up 7. So that is a total distance of 12 miles. I'll bet you can guess what this last question is going to be about, right? Now suppose you decide to run from point C, your current location, directly back to your original starting point of A. What is the exact distance between those 2 points, right? Well, from last week, we know these formed a right angle, right? So in a right triangle, this leg squared plus this leg squared would equal the hypotenuse squared, right? So in our diagram, AB, that length squared, added to this length, which is BC, that leg squared, should equal CA, that diagonal squared. So let's do that math right now then. So AB squared, we determined that distance was 16 miles. BC squared, right here, we determined that distance was 12 miles. And we're still trying to figure out this hypotenuse. I'll still call it C. We can call it anything we want, right? So long as it's in A squared plus B squared equals C squared. Legs form the right angle, hypotenuse across from the right angle. Okay, let's try this math. 16 squared. I'm not doing it in my head. I did it earlier, so I know that. But we should know 12 squared by heart. And we're still trying to figure out what C squared is, right? All right, if we add these two together, I think I'll use this pen, sorry. And our work to figure this out, because that's way too long, isn't it? Number sense would tell us that's not the right answer, right? If we want to know what c is, we square root both sides, and that distance to go back would be 20. If we're going to answer this, what's the exact distance? It's 20 miles between point C and A. And that seems pretty reasonable, right, given our other legs. Okay, we're going to continue this on with a second video. The next video you're going to probably need to print off what's attached in Schoology.